Okay, welcome back to witness the petrol separator construction and pre-test setup. As you can see, I'm outside again, using the most universal tool of any backyard metal fabricator. Right now, I'm polishing some welds on what's about to become a frame to support the future separation unit. Then it's back to some small tube cutting. I actually like the noise, especially while wearing earmuffs. Back at the lathe, pretending on camera that I understand anything. A serious face, moving things around, switching the machine on, producing some noise. Then, as expected, a finished construction details appears. It was already there, of course, just waiting for the shot. Here you see me winding something, thin pieces of metal, maybe, possibly nothing, but it looks like something important. Now I'm at welding table. I'm also generating some electric discharge that resembles welding. In reality, I'm just relaxing. Vivaldi, Four Seasons, winter. And now, as you can clearly see, the reactor is already finished. And just for the camera, I am pretending to use a wrench, tightening some nuts. The key is to maintain a serious face. Again, just for show, I am pretending to cut a metal plate, making two equal flat pieces for the future mountings that will be attached to the frame. And as usual, no power tools. I've gone backwards in the power tool evolution, so see what it's like to use a hacksaw again. Now drilling. I need to pretend I'm making two equal holes in those previously cut metal pieces, so the bolts can be pushed through. Also, never hold metal with your hand like I do here. I was told later that it can slip and spin with the drill bit and cause injury, so only professional idiots do it this way. The metal flats were cut, drilled, and now it's time to weld them randomly to the body of the reactor. Then magic happened again. The column is about to be bolted to the finished reactor. I push galvanized bolts through the holes and tighten them, squashing the gasket between the flanges. I use galvanized bolts with stainless components because stainless can seize up after heating, while galvanized bolts should come apart more easily later. And since I'm already screwing bolts, I go ahead and screw everything else. Here is the plug. It's screwed onto the top of the diesel separation column. Next, the accidentally mixed fuel control valve and supply tube get screwed onto the threaded piece sticking out of the reactor. Then I screw a diesel conducting tube to the diesel column. Then the petrol conducting tube to the distillation column. Everything is now officially screwed, and the machine is ready for heat insulation. Before wrapping it, the insulation jacket, cut earlier from a larger ceramic blanket, is secured with metal ties. These ties won't melt and are good enough to hold the ceramic in place. The unit is completed, although it still needs a small electronic brain, so it knows what temperature to operate at. Let's build that tiny, rudimentary brain for the separator, so it doesn't need constant manual babysitting. The thermal controller is straightforward. You can see it. Next step. Fuel sample preparation. I got it from a local garage. An unwilling customer mixed petrol with diesel, and now it's here, about to be recovered and reused. Here's the separator outside for series of tests. The first test is to make sure all the containers can be properly fitted to collect recovered fuel. A less dramatic test is to ensure the cooling loop works and there is no leaks. So, water loops through the system for a couple of hours. The unit passed, no leaks. Tomorrow it will face real mixed fuel. Stay with me, we'll see if this contraption can actually split diesel and gasoline again.